Has MO theory failed us? Why has dihydrogen anion never been observed when the molecular orbital theory predicts a stable molecule? Let's take a look at the MO diagram. We have a normal hydrogen bringing in its 1s electron, and we've got another one, the hydride anion, bringing in 2 electrons. When atomic orbitals combine to form molecular orbitals of this molecule, you get a bonding orbital. This one's called the sigma 1s orbital, and that's lower in energy. That's where these electrons want to be. One of these electrons has to occupy the antibonding orbital. We call that the sigma 1s star or the sigma 1s antibonding orbital. So one of them's got to go in there in the higher energy space. So if you calculate the bond order, you are right. You do get a bond order of about half, which is about half a bond, which is greater than 0, which does predict a stable molecule should exist. So why don't we see this? Well, a couple of reasons for that, probably many reasons for that. So even though molecular orbital theory is challenging for many first-year chem students, it's still a relatively simple model. And even complex models, all models have limitations. So here's the nuclei of the 2 hydrogens, and let's say this here represents the bonding orbital, and you've got those electrons right there between the 2 nuclei that are positive. They're great, but that one electron in the antibonding region is somewhere there or somewhere there, and it is decreasing the stability of this molecule. Hydrogen is a very small molecule as it is, so when you're adding an extra electron, that's going to feel an extra repulsion. So MO theory doesn't account for a lot of things that happen in reality. Another thing to consider is maybe it does exist, but it's so unstable or so reactive that it's just difficult to measure. Let me leave you with this final related thought. Consider the beryllium molecule, Be2. According to MO theory, this molecule shouldn't exist. But if you take a piece of beryllium metal, you'll find moles and moles of the stuff bonded together. So scientists use these models and theories to best explain in the simplest way what we observe in nature. And oftentimes we need a lot of models. In this case, we might need